Alright, Unit 7, inverse trig and vectors. Going ahead and do our review here. Problem number 1, find the component form of the vector r in the same direction as the vector u, which we're told has a horizontal component of 1 and a vertical component of 5. So this is clearly not drawn to scale, but that is just fine, doesn't matter. So what we should do is figure out what is the hypotenuse of this right triangle. If we're thinking of this vector as a triangle, what is the value of the hypotenuse? Well, 5 squared is 25, 1 squared is 1, 25 plus 1 is 26, so we get the square root of 26 right there, which we can't really simplify because it's 2 times 13, both prime numbers, so we will leave that. We want a vector in the same direction, which means the ratio of the horizontal component to the vertical component has to be the same as in this triangle right here, aka they have to be similar triangles, which means we can set up a proportion. We know the magnitude should be 4, so the magnitude is corresponding to the hypotenuse right there, and we can find the x and y components by setting up a proportion. So let's go ahead and do that. Let's say x over 4 equals 1 over the square root of 26. First off, notice I put the x in the numerator because that's what I'm trying to find. That just makes my life easier. And I took the horizontal component of the small one divided by the vector. And then over here I took the horizontal component divided by the vector right there. Now to solve this, I need to rearrange my equation, multiply by 4 on both sides to get x equals 4 over the square root of 26, which I will rationalize to 4 times the square root of 26 divided by 26, which will simplify, I should say, to 2 root 26 over 13. So that is my horizontal component right there. Let's do the same exact thing now to find the vertical component. I'm going to say y over 4 equals 5 over root 26. Similar setup. And then again, I'm going to get y equals 4 times 5 is 20 times the, what am I doing? Let me show you this actually. This will make it a little bit easier for us. I'm multiplying that 4 up, so I'm going to get a 4 times 5 in the numerator there, and then the root 26 in the denominator. And then we want to rationalize that. 4 times 5, I'm going to leave it like that for now, times the square root of 26 divided by 26, because I know that that 4 and the 26 is going to simplify to a 2 and a 13. So I can rewrite this as 2 times 5 over times root 26 over 13, and now I can combine the 2 and the 5 to say that I have 10 times the square root of 26 over 13 as my final value for that y component. So when I then write this as a vector, I'm going to get the horizontal component, which is 2 root 26 over 13, comma the vertical component, which is 10 root 26 over 13. And that is my vector.